Most engineers extract coordinates from Google Earth the wrong way, copying them one by one. If you have 50 or 100 points, it can take hours, and only one tiny mistake can ruin your project. In this video, I will show you the professional workflow to extract coordinates directly into Excel, fast, accurate, and error-free. This is the exact method engineering consultants use when preparing survey tables and hydraulic models. By the end of this video, you'll also understand how the workflow works so you can handle even large data sets confidently. But first, let's look at why the traditional copy-paste method fails and wastes so much time. So what people normally be doing is they come, get a place mark, they come and put it where they want it to be. Then they come and open Excel. Come, copy this thing, paste it here, go back, copy another thing, paste it here. That is their transition line 1. They want the second one, they go back, they do okay. They want another point, they come in the transmission line 2, come and place the marker where they want to, let's say here. Then they come and copy the east thing, come and paste the northern, come and paste. So the problem to this approach is it is slow because you have to pick one point at a time, and this is also error prone because a single mistake shifts the location by kilometers and it's also unprofessional because large projects really require structured data. So let me show you how to fix this issue. So to fix this, we can check on our temporary places like this, right click on it, add a folder. I want to call it a transmission line TL. So you come on TL, you can either click like this, then you add a polygon or a path. So this is one method, or you just come click on it like this, then you come and pick the tool you want to use from up here. Let's say you're going to draw a line for a pipeline. Digitize the route for the pipeline, something like this. The reservoir at this point. So this is our TL, it's our transmission line. And change the color to blue. And then the width is to 3 so it is more visible like this. This is how you digitize. Then if you want another point, let's say you want to put the reservoir and also add a folder, okay, call it reservoir. So we have the reservoir location here. Let's click on it, add a point or a place mark. Let's just, since the point, I want to have a place mark. It's our reservoir location. So we have this, you have the reservoir and also the transmission line. So what you can do now, just save this file. Want to come and save places. Let me save it. Once that is saved, we are going to use GPS visualizer for the next step. So you just come and Google GPS visualizer. If you don't have it, check on the link in the description. When in GPS visualizer, you want to come to convert a file. Click on it. So come and choose our file from here at this point where it says upload your files here. So we have only one file. You're going to come and choose our file from here. Come and select our files. If you had more than one file, maybe you also add for the distribution line or distribution lines, intake point, questions for the tabs, you also come and add them here. In case you extracted them separately, you come and put them here. If there are more than 3, click on this box takes you up to 10 files that can be uploaded. So since for us we only had one, we have already done ETL. So you don't come and just convert. We are going to keep it in plain text. You can change to GPX or Google HTML, but for us we want ours in plain text. So we scroll down here. There are two important things we're supposed to do. The first one is going to be this point which says add them elevation data. Come and click on it, and then we're supposed to select this based on the project location. The data you're collecting falls under which location. So if you are maybe in North America, you can use this. In Alaska or Northern and Western Europe, you look for your location around this point. But if your location is not here, you can come and choose best available source. So for this tutorial, we are going to use best available source. So come and check on this. Then the next one is just come and open this show advanced options, and then not waste time, just scroll way down here. Then come to this very point where it says output UTM coordinates. You're going to say yes, because you also want to get the UTM coordinates. So now from here we come and click on convert. So it's going to download it, which is here. Once downloaded, we are going to open it. So this comes as plain text. You can see a lot of information here: the latitude, longitude, UTM, easting, northing, and then the altitude plus other information here. So now what we do, we come to our Excel. So we come to Excel. When open our Excel sheet, we come under data here. Then we come to get external data. Say from text. And we go to the folder where we had our text. Import it. We are going to leave it here. Come and click on next. It's going to align all these things that we are seeing. Click on next and finish. Okay. So you can see our data. Our data has been input here. So now we can do some little trimming. Make sure our things are okay. So for my case, I'm going to delete this point. I don't need this. The name is a description. Remember, our first point reservoir is here. Then our transmission line, the different points that were picked here. We are going to keep that. Here we also delete. This is northern. This is elevation. Our description. So here you have your data. So this is how it's done. So you can now take this and do your next engineering task. So this is the best professional method that you can adopt for your data extraction. The reason why this works is because Google Earth stores coordinates in KML format, as structured text files. So instead of manual copying, extract everything at once, just like you saw, in just one folder. So this workflow is faster, more accurate, and even looks more professional. This approach is the standard among consultants for projects involving pipeline routing, dam hydrology, survey layouts, even for reservoir planning. Please don't forget to subscribe to learn more practical engineering workflows.